Okay, we're going to do this from the tablet and not from the whiteboard in Casa de Jackson because we want to be able to graph it and get something accurate out of this. So I'll do my best to go quick because I know it's kind of boring when you're just staring at a screen like this. We're going to graph this cosine wave, which only has two transformations, right? We talked about what these transformations are. We've got a horizontal transformation here on the inside and a vertical transformation here on the outside. And we're going to take care of the horizontal transformations first, then we're going to take care of this vertical transformation second. But when we come to graph this, you have to have a basic understanding of how a cosine wave behaves, right? Max to intercept to min to intercept to max. And the spacing of these critical points is consistent. Okay, the horizontal distance from point to point is the same. Keep that in mind once we start messing around with our scale and the change in x. Okay, so the way that we start these graphs off is we find out how this horizontal transformation affects the beginning and end of the period. So LEP, I'm abbreviating for the left endpoint. So the left endpoint of a cosine wave should have an x coordinate of 0. Here's the first point in the period of cosine. It should be at 0, right? So we set this for x equal to 0 and we solve for x. Divide both sides by 4 here and you still get 0. So we're not shifting this point, this first critical point, away from where x is 0. The right endpoint, same concept. Where is the right endpoint of a cosine wave supposed to be? The rightmost endpoint of the period is supposed to have an x coordinate of 2 pi. Okay, so we set the for x equal to 2 pi, and we solve for x. So again, divide by 4. I didn't show you this in the one right above, but that's fine. We get x equals 2 over 4 with a pi attached on the top. 2 over 4 is 1/2, so we get pi over 2. So we know where the period stops. We know where it starts. So based on these two values, we can find the length of the period. The period is equal to, you have two options, right? Since we know where it stops and we know where it starts, if we subtract those two values, we get the length of the period, which is pi over 2. The other option for finding the length of the period, and this is something that we talked about, is to take 2 pi and divide it by b, right? Now b is the value that's in front of x. Okay, we showed, there it is. B is always the coefficient of x on the inside of these parentheses, whether it's a sine wave or a cosine wave. So since we have a 4 here, we know that b is 4. So we could say 2 pi divided by 4 to get the length of the period, which gets us pi over 2. We don't have to do both of these. This is just me demonstrating how it can be found. So we know what the length of the period is. Now, the period of a cosine wave, for what now, the third or fourth time we've talked about this, starts here, goes down, comes back up, and ends right here. It's supposed to take from 0 to 2 pi for that to happen. But the cosine wave that we're going to be looking at, it only takes from 0 to pi over 2. But regardless of that, we have to take the period and break it into these 4 intervals so that we know where to put these points. Okay, so we're going to take, after we find the length of the period, we want to know where these other 3 points are. We know where the left endpoint is. We know where the right endpoint is. We find the change in x by taking the period and cutting it into those 4 pieces. So this is going to get a little weird, right? Because we're taking a fraction and dividing it by a whole number. Okay, but if we break this down, that would be pi over 2 divided by 4 over 1. If we take the 4 and turn it into a fraction, this is a different way of thinking about that or rewriting that expression, which is pi over 2 times 1 over 4, right? When we divide by a fraction, we multiply by the reciprocal. So for the change in x, we get pi over 8. And that's what we're going to make our scale. Okay, so we're going to come up here and we're going to say this is 0. This is pi over 8. And I'm just going to count by pi over 8. So this is 2 pi over 8. This is 3 pi over 8. This is 4 pi over 8. This is 5 pi over 8. and this last one is 6 pi over 8. Now, obviously, some of these can be reduced, right? And you should have an idea of that. Like 2 over 8 is really 1/4. Okay, but what's really key here is this one, because what is 4 pi over 8 equal to? 4 pi over 8 is equal to pi over 2, right? Do the reduction here. 4 over 8 reduces to 1 over 2. So we have 4 pi over 8 is the end of the period. So we know the first point, right? We said the first endpoint is where x is 0. The last endpoint, 4 pi over 8, the last critical point is here. And then we have the other 3 points that are evenly spaced out. One here, and one here. Okay? Now, I'm going to erase that real quick and just talk about a little bit of a shortcut that you can think about here when you're graphing this. Okay? We know where the period starts, we know where the period stops, and we know that these points are spaced out into fourths, right? And this is how it's always going to look, whether it's minimized, whether it's stretched out. A cosine wave is going to look like this. The minimum value right here is always going to be, always going to be the halfway point between the beginning and end of the period. It's always going to be right here in the middle, right? So this is 0, this is 2 pi. Directly in the middle, that's where the minimum point's going to go, right? Now, if you figure out where that point is, now when we come back here, just as a bit of a shortcut, we know where, since this starts here and it ends here, go halfway in between. That's where the minimum is going to be. Now, we'll talk about where that point goes in terms of its vertical placement here in a second, okay? But where's the second point in a cosine wave? The second point, here's the third, right? Here's the third point right here. Here's the first point right here. Where's the second point? It's halfway in between. So rather than, adding that pi over 8 and adding pi over 8 and adding pi over 8 like we did in class, we can take a little bit of shortcut and say, well, I know where it starts. I know where it stops. I know there's got to be a point directly in the middle of that. And then in between these 2 points, I have another point. And in between these 2 points, directly in the middle between those 2 points, I have another point. Okay, so that's a bit of a cheat code or a shortcut for finding the placement of these 3 inside points here. Okay, once you know where the first and last is, go halfway in between, and then find these 2 values. Now, you're still going to be asked to find the length of the period, so don't skip this step. And this step right here, it helps us scale the graph. So it's still kind of important to find this delta x, or the change in x value. Okay, now after we get our x coordinates taken care of, we worry about the y coordinates. The y coordinates of a cosine wave, again, based on this, are supposed to go from 1 to 0 to -1 to 0 to 1. So the way I'm going to make a shortcut for this is when I go to find the y coordinates here, 1, 0, -1, 0, 1. Now I come back and I look at this and I find that vertical transformation here. So I'm doing 3 times the cosine wave, which means I'm taking 3 times the value of the wave. These are the values that I'm supposed to see on a cosine wave. So all I do is take each one of these values and I multiply each one times 3. That's going to be that vertical stretch that we talked about. So now instead of being at 1, 3 times 1 is 3. 0, 3 times 0 is 0. 3 times -1 is -3. 3 times 0 is 0. 3 times 1 is 3. So now I can go back over here and Dr. Dre these points to where they actually belong. Okay, this point is not at 0, it's at +3. This second point had a y coordinate of 0. This third point had a y coordinate of -3. This was at 0, and this was at +3. Now again, here's another bit of a shortcut. Once I know where the first point goes in this cosine wave, the last point's going to be on the same horizontal line with it. It's not going to be above or below because they're both maximum points. So once I know where that point goes, I know this point's going to be in the same spot. Same thing is true for the second point and the third point. So now when I go to draw this, I'm going to try this on this tablet I have here. Might not be perfect. We get something that looks like that. That's one period of this sine wave, something we haven't done a ton of, but you still need to practice is, this is one period, but I should fill the entire graph with this cosine wave. So I typically start with the right point when I do this, and I just mark off intercept minimum, intercept maximum, intercept, then it's going to go to a min, then it's going to come back up, then it's going to come back up, then it's going to go back down, then then it's going to go back down. So we get, my drawing's not going to be perfect here. We get this wave action. So then here, this is a min, intercept, max, intercept. This one's going to end at that minimum point right there. Okay, so a couple of shortcuts shown here try to help you out, make this process a little bit simpler.